Today our focus is on solving for a variable. Most of this should be review, but I'm going to go ahead and give you some help just to make sure you know what you're doing. So question number 1. We're supposed to identify the set of angles within the parallel lines. So we want to know what relationship these two angles share. I recognize that these two angles are on alternate sides of the transversal, and they are both inside the parallel lines. So I would identify this as alternate interior angles. That's beneficial to us when solving for a variable because we know that alternate interior angles are congruent. Congruent meaning that they are equal. So whatever is in one angle, 45 degrees, is equal to what is in the other angle. So 9 times 2x minus 3. Now there are multiple ways to solve this particular problem from this point forward, but I'm going to stick with the one that follows our general rules. And our general rules always recommend that you distribute first. So 9 times 2 is 18x. 9 times 3, 27 equals 45. So we distribute, we combine like terms, and then we isolate the variable. There are no like terms that need combined, so we're going to isolate the variable. So to do so, we will add 27 to both sides. So when we add 27 to both sides, we end up with 72 equals 18x. And then to get x by itself, we divide by 18, and x is then equal to 4. Question number 2. Question number 2 is again alternate interior angles. Both of these angles are inside the two parallel lines. They're on alternating sides of the transversal. So they are equal to each other. 60 is equal to 15x, and this is a much simpler problem. Divide by 15. X is again equal to 4. Number 3. This time we're on alternate sides of the transversal, so alternate, except we're outside the parallel lines, exterior angles. Well, alternate exterior angles are also congruent, so we can say 158 is equal to 2x squared plus 30. So again, we want to isolate the variables, so we're going to subtract 30 from both sides. And we end up with a 128 is equal to 2x squared. Well, now I need to ask myself, do I deal with the multiplication or do I deal with the exponents? Remember that when we're dealing with solving for a variable, we're working order of operations backwards. So SADMAP. Oops. MEP. Sorry about that. Let's try that again. SADMEP. And so when we're dealing with SADMAP, we have subtraction, addition, division, multiplication. Definitely comes before an exponent, so we're going to undo the multiplication. The inverse operation of multiplying is dividing, so I'm going to divide by 2. So 64 is equal to x squared. Well, x squared is equivalent to x times x. So what two numbers that are the same value multiply together to give us 64? Well, that would be 8. Or for those of you that already know the 8th grade content, you'll know that that can give you plus or minus 8. At this point in your mathematical understanding, I'm fine with you recognizing that 8 is the square root of 64. You will clarify that a bit next year. Number 4, identify the angle relationship. Well, we have two angles that are adjacent to each other, and those two adjacent angles form a straight line, so that's simply supplementary angles. And supplementary angles, we should know from way earlier in this year, add up to 180 degrees. So 2x plus 4 plus x plus 8 equals 180. And so again, you would combine like terms, isolate the variable. Let's look at number 6. The absolute value is getting multiplied to x minus 2. Well, if we really wanted to, we could go ahead and clean that up. The absolute value of negative 2, well, that's 2, is getting multiplied to x minus 2. So 2 times x is 2x. 2 times 2 is 4. So this entire phrase is the same as saying 2x minus 4. Well, I can see that I have two angles on the same side of the transversal. So by the time I've said same side, I should only be thinking of one angle relationship. Same side interior angles. Now, same side interior angles have a supplementary relationship. So this angle plus this angle are going to add up to 180 degrees. We already said that this angle here simplifies to 2x minus 4, so that's going to make life a little bit easier. And we add that to our other angle, 3x plus 9, where we can start to combine like terms. 2x and 3x is 5x. Negative 4 and positive 9 is positive 5 equals 180. So 180 minus 5 gives me 5x equaling 175, where x is now equal to 35. Question number 9 tends to be a tricky one from year to year because we don't have a relationship that is on alternate sides of the transversal, where one is outside the parallel lines and one is inside the parallel lines. So this one requires a little bit of adaptive knowledge. I could say that 125 goes here by vertical relationship, which would then give me two angles that are same side interior. And I know that the two angles that are same side interior are supplementary. So it would make sense that 4x minus 5 and 125 are supplementary angles. Now, you could have used any combination of our angle relationships to get that same conclusion. I could have said 4x minus 5 is alternate interior here. So now my 4x minus 5 and my 125 are two adjacent angles that are supplementary because they form a straight line. Number 8. Number 8 is our application of the exterior angles theorem. And so we should remember that an exterior angle is equal to the sum of the two remote interior angles. Well, what do we mean by remote? We mean not adjacent to. The interior angle that is adjacent to that exterior angle would be this one right here. A is adjacent to the 14x angle. Just like using a remote on your TV, it allows you to sit in your couch and not have to get up to touch the TV. The A is the only angle touching the 14x angle. These other two angles are remote. So we could say that 14x is equal to 63 plus x plus 15. Well, now we need to first get all of our x's on one side of the equation, so I'm going to subtract x, 13x, and then I'm going to add my 63 and 15 to equal 78. To get x by itself, we divide by 13, and x is equal to 6. Number 11. Number 11 is a very similar problem, but is actually easier than number 9. Number 11 is not exterior angles, but rather all of these are their vertical angle. And since all of them are their vertical angle, all three of these angles will add up to 180 degrees, and we can solve for x. Let's look at this on the bottom. Now, you may not remember, but we actually did this way back in Unit 4 earlier this year. We did it as a class. Now I want you to try doing it on your own, since we've added quite a few angle relationships. I am going to post a completed answer key, so you can certainly come back and check your solutions, but I encourage you to give it a try first. Let me give you a really big hint. One big hint, this is a 90-degree angle. Second big hint, these two side lengths within the triangle are congruent. Since they're congruent, think about what that means for their opposite angles. I will check back in with you on another day. Have fun.